Hello everybody and welcome to my class. Today we are going to be studying some algebraic equations, and this will be the 7th grade curriculum. And this is a continuation of last class. So this is our schedule. First we're going to review how to graph points on a coordinate plane. I'm sure you all have a basic understanding of that. And then we'll learn about slope and y-intercept. And these two skills will build up to our final subject on our schedule, which is studying the slope-intercept form in linear equations. Okay, so let's first start with a small review of the coordinate plane. So on the coordinate plane, the horizontal line would be the x, right? And then the vertical one would be the y. And when you graph a point, let's say right here or right here, any point on the line, you have to express it in this x and then y coordinate form. Okay, so always when you graph a point, it will be in this form. Okay, and then let's do a small warm-up exercise. Please graph 5, 3 on the coordinate plane. Okay. For this question, you can't really put it in numbers, and you can't really post your answer in the chat box. But I would like you to try and do this warm-up exercise, okay? And get your brain warmed up for next subjects. Okay, so please do this warm-up exercise. Okay, so please graph 5, 3 on the coordinate plane. You can draw a coordinate plane on your own paper and then graph it. Okay, this will be a small warm-up exercise. So I'll give you a bit of time to do that. Okay? So let's do another warm-up one. I want to make sure that you know how to graph a point on the coordinate plane. Okay? So let's say graph 4, 2 on the coordinate plane. Okay? So these are just small warm-up exercises. You don't really need to put the answer in the chat box, but please do them to warm up your brain. Okay? So is everybody done with that? Just graph it on your own paper, okay? Just graph it on your own paper. Okay, so I assume that most people are done with that. It was pretty easy, okay? Now, let me get to business. Okay. So, later on, when we do some practice problems, I'll ask you to find like the distance between some points. Let's say we have 1, 1 right here. Okay? And then let's say we have a 6, 1 over here. 1, 6 over here. Remember, x is first. Okay. So 1, 6. Yes, this is 1, 5. 1, 5. Okay, so now that we have 2 points, try to find the distance between them. So these two are on a straight line. It's very easy to find the distance between them, right? If it's on a straight line, then see which coordinate they are equal. Okay, so in this question, okay, the x-coordinate is equal, right? So you don't have to worry about the x-coordinate. Just subtract the y-coordinates, 5 minus 1, and you get 4, right? So that is the distance between 2 points. But now, how do you find the distance between, let's say, 1, 1 again, and let's see, 1, 2, 3, 4, 6, 6, 2, okay? How do you find the distance between the coordinates that are not on an exact straight line in the coordinate grid? Then you have to use the Pythagorean theorem, okay? Because you have to notice that you can form a triangle using these, and then using the Pythagorean theorem, you can find the distance between them. And also, using the Pythagorean theorem, you can also find the middle point of these two coordinates. So let me review the Pythagorean theorem for everyone. Okay, so the Pythagorean theorem, the formula is a squared plus b squared equals c squared. Okay, this is a theory applied on right triangles. So let me draw a quick right triangle right here. And it has to have a right angle, okay? So let's say this is B. And then this is C, okay? And then using the formula right here, we can figure out C with A and B, okay? So let's practice using the Pythagorean theorem, okay? 5, 4, and now what is C? Please use the Pythagorean theorem to try to find C, okay? I gave you 2 dimensions, and now try to find C, okay? So I'll give you a few moments to answer this question, and then you can post it in the chat box. So please answer this question. Okay. So has everybody figured it out yet? Okay, so Jocelyn says the square root of 41. Very good, very good. Okay, so we have a lot of answers. I'll give you a few moments. I see that a few students haven't answered yet, okay? So I'll give you a few more. Okay, so I give you a few moments. Okay, so everyone has square root of 41. Okay, very good. So you just do 4 squared plus 5 squared, and you get 41, right? But remember, you have to square root that, because in the end you will get c squared, not just c. So don't forget to not do the square root. Okay, so now let's practice with some practice problems, and then we can move on to some harder subjects. Okay, so this is our first practice problem. This is number 1. Find the distance between the 2 points, 3, 4, and 7, 4. Okay, These are just on a straight line, so you should be able to solve them pretty quickly. Okay. Okay, so most of you said 4. Okay. 4. Any more answers? Okay, 4. So everyone has 4. That's very good. So remember, we have the same y coordinates over here. We just don't have to worry about it, and then we just subtract 7 minus 3, right? Okay, and we get 4. But sometimes maybe you just do 3 minus 7. You get negative 4. That's not the distance, right? So every time you subtract it, you have to take the absolute value of it. Okay? You have to take the absolute value. You can't just leave it to be negative. Okay, so does everybody understand why I need to take the absolute value of the thing? Okay, good. So now let's move on to something a bit harder. Okay, so number 2 is to find the distance between 3, 4, and 4, 5. Now this is not on a straight line. So can you guys find out how to use the Pythagorean theorem to try and find the distance of these 2 points? Also, after finding the distance, please find the middle point too. Okay? Find the distance and the middle point. Okay? So find these 2 things. Okay? And please post them in the chat box. Okay. Has everybody figured out the thing yet? Using the Pythagorean theorem. Okay? So this is actually a bit more complicated than just a single line. I'll give you a bit more time. Okay? And if you just don't know, then you can post in the chat box that you don't know. Then I'll walk you through it, okay? So I'll leave this slide up, and please try to do the questions, okay? Okay. Carney says the square root of 2. And Tracy says 1, 1. Okay. So, any more answers except for Carney and Tracy? Okay. So it seems that there aren't any answers. So let me solve this. Okay? So let's draw a coordinate graph first. And let's just estimate where these points are going to be. Okay, let's just estimate. So we have 3, 4. So x first, y second. Estimate it be here, okay? And then we have 4 or 5. Let's estimate it to be here. Okay. So something like that. And then you form a triangle with it. Okay. So these estimates aren't exactly perfect, so you don't have to pay attention to where the points are. But the point is that you can form a triangle with it. And then to find the distance between the 2 points, remember this this line that is usually called C right here. Let me go back to here. Okay, so this is C, right? The longest line. If we go back here, this will be C, and now we just have to find C to know the distance between these 2 points. Okay, so how do we find the C? Okay, so the formula for the Pythagorean theorem is a squared plus b squared plus c squared, right? Now we just have to find a and b. And this, let's say a is right here and b is right here. Then it's very easy, right? You just subtract the x coordinates, subtract the y coordinates, and then you get a and b, right? Okay. So let me get a larger scale version of this. Okay, so this, a larger scale version, this is our triangle. Okay. This will be easier to work with. Okay, this is C, A, and B. So these 2 points, this is 4, 5, right? This is 4, 5, and this is 3, 4. Now we have to find B. B is vertical, right? So we have to subtract the y coordinates. Okay, and A is horizontal, right? So we have to subtract the 2 x coordinates. So then our formula will be like this. x2 minus x1 squared. Don't forget, you have to square A. So this entire thing will be A plus y2 minus y1 squared. So this entire thing would be B. And then, remember, this would equal to c squared. But we don't want c squared, we want c. So what do? We take the whole square root of the thing. So this will be our formula. So does everybody understand so far? Okay? Does everybody understand? Okay. Tracy, what do you not understand? I will explain it again for those who don't understand. Okay. So the square root in the formula, right? The square root in the formula, because, okay, so I'll simplify it again. So actually there's a stage before this whole formula. This is a squared, right? The x minus the x, okay? Squared. And then the y2 minus y1 squared is b squared, right? And then, oh wait, no, this is not the formula. Equal sign, okay? And then you can turn it into this, right? So a squared plus b squared equals c squared. And then to get c, we have to get c, right? That's the big goal. We have to get c. So we square root on both sides. And then it simplifies to this, right? So that is our big formula. Now we just have to plug in numbers. We just have to plug in numbers. So you can, let's say we, x2 is 4, okay? So you have 4 Okay. And then x1 would be 3. Okay. So we've got these two numbers already. We have two more numbers, okay? The y-coordinate. So what is y2? y2 can be 5. Now why can't it be 4? Because x2 and y2 have to be in the same the parentheses, okay? So if x2 came from here, then y2 also has to come from here. It can't be like this. It can't be x2 and then y2 right here. No, it can't be like that. So it has to come from the same coordinates, okay? So then you'll know that this will be y2, and then the 4 will be y1, okay? And then we have to solve the formula, okay? So this will be very easy because these are very easy numbers to work with, okay? So 4 minus 3 would be 1, right? And 1 squared would be 1, right? And then 5 minus 4 squared is 1 squared also. Then we can simplify just to 1 plus 1. And add in the square root, this actually equals square root of 2. And what is the square root of 2? Well, square root of 2, that is an undefined number, right? It's a random, non-repeating decimal, okay? So we can just leave it as square root of 2, okay? Leave it as square root of 2. Okay, and that will equal to C. And we find the distance between these 2 points. So does everybody understand now? Okay. Yes, Carney, that's right. Whenever there is a right triangle with the sides 1 and 1, would be the hypotenuse would be square root of 2, okay? And remember, we still have to find the middle point. But now we found the distance. The middle point is easy, right? We just have to find the average of it. The distance, okay? Or you can just divide by 2, okay? Just divide by 2 and you get the middle point. So the middle point is really easy, divide by 2, okay? So now let's move on to the slope and y-intercept, and then we'll get into slope-intercept form. Okay, so the definition of a slope is the steepness of a line, okay? And it can be represented as vertical change over horizontal change. Now this vertical over horizontal actually is y over x, okay? It's y over x. And you can find slope by doing this. y2 minus y1 over x2 minus x1. So basically you have to have 2 points to find the slope. Okay, so I'll repeat. The slope is the steepness of a line and it can be represented as y over x. Okay, the vertical change over the horizontal change. Okay, so now let's do a few warm-up exercises to make sure you understand what slope is. Okay, so we have a coordinate graph right here. Okay, and let's see, let's have a 2, 2 right here, and then we have a 6, 6. Okay, so please solve the slope of this. Okay, just y2 minus y1 and x2 minus x1. Okay. So please put your answers in the chat box. So Jocelyn says 1. Okay. Very good. Any more answers? Tracy says 4, 4. Okay. And then Frank says 4 divided by 4, which is 1. Okay. So let me walk you through it now. So we just have to do y2 minus y1. So we have 2 y coordinates. And then we just have to subtract these two. So this will be y2, this will be y1. Okay. 6 minus 2 equals 4. Okay. And then we have 2 x coordinates. This would be x2, this would be x1. Okay. And then we just subtract it. 6 minus 2 equals 4. So basically it would just be 4 over 4, which is 1. Now why isn't it negative 1? Why can't it be 6 minus 2 divided by 2 minus 6? It would be negative 4 over 4. As I said earlier, the y2 and the x2 have to come from the same place, okay? They have to come from the same place. So they come from the same coordinates, right? Look, the x2 and the y2 from the same coordinate, and the x1 and y1 from the same place. You can't have the y1 from one place and the x2 in the same place. Okay, you can't have that. So that is why the slope is 1. Okay. So now let me explain the y-intercept. Okay. So the y-intercept is where the point where a line on the coordinate plane crosses the y-axis. Okay. So basically, you have a line, and it crosses the y-axis right here, right? So that would be the y-intercept. Okay. So any line, just it's the point where it crosses the y-axis. Okay. Okay. So here are some helpful tips, and they'll come in use when we talk about the linear equations, okay, and how to graph them. And as I know a lot of you went to my previous 5th and 6th grade classes, you might think that this slope and y-intercept you already learned in the 5th and 6th grade class of mine. And yes, you did learn this. But last time we weren't graphing linear equations. We were graphing inequalities. And then also, in this 7th grade class, we'll work more with graphing these linear equations. Okay, 6th grade, graphing the inequalities, that was just an introduction to this. So there will probably be an algebra 4, okay, maybe next class. And then I'll teach you more deeply on the graphing these linear equalities, and then or linear equations and linear inequalities. And then we might work on compound inequalities or absolute value inequalities, okay? So we'll go deeper on this in the 7th grade class, okay? So now I'll give you some helpful tips, and these are actually pretty helpful when you're solving for the slope-intercept form, okay? So always remember, if you graph a line like this, the slope is negative, okay? Why? Okay, so everyone knows this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4, okay? So all of you have learned about coordinate geometry, and this is just very basic coordinate geometry, and you should know about these quadrants. Okay, so let's look at quadrant 2. Quadrant 2, okay? This is the y-axis right here, and this is positive y-axis, okay? Because it's going up. It's going up. But this is a negative x-axis because it's going left, not right, okay? So this quadrant 2 contains negative and a positive. And a positive divided by a negative, okay, is always a negative, right? So let's see. Negative 1 divided by positive 1. It's negative 1, right? So that is why our slope will always be negative. Okay? Look at quadrant 4. The same. We have a negative y-axis and a positive x-axis. So then you will have a negative slope. But it's a different story when you have a line like this. Okay? Then it's going left to right, uphill. Okay? So let's look at quadrant 1. We have a positive y-axis and a positive x-axis. Then we have positive over positive, which makes a positive slope, okay? And then you have in quadrant 3, you have negative over negative, which also it cancels out the negatives and that turns into a positive, okay? So this sounds pretty easy, but this will be helpful when you're rechecking your work, okay? So when you're graphing these linear equations, it's always a good idea to check your work, okay? So now let me introduce linear equations. Remember, last class we solved algebraic equations, which was like, let's say, x plus 4 equals 5, okay? Something like that. But linear equations, okay, usually sometimes, and even I make this mistake, is that some people mistake linear equations for just single variable algebraic equations, but you can't do that. Linear equations, they have two variables. You have an x and a y, okay? You have an x and a y. And these, you have to have an x and a y, or you can't just plot a line on a coordinate grid. So maybe a linear equation would look like y plus 2 equals 3/4 x, okay? Something like that, okay? So following my example, can everybody do this warm-up exercise, okay? So please make up your own linear equation, okay? So please try to make your own linear equation, okay? Okay, so Ray Shan says y equals 3x plus 4. Okay, very good. And then connecting says 3x equals 4 divided by y. 4 divided by 5, y. Okay, very good. And then Tracy says yx times 2xy. Okay, Tracy, this is not an linear equation. Why? Because it has to be an equation. There's no equal sign in your expression, Tracy. So remember, you always have to have an equal sign. And Jocelyn, very good. Okay. So these are just examples of linear equations. Now, the definition of a linear equation is a algebraic equation that can be plotted as a line in a coordinate grid. Now, sometimes you have like x squared or something like that. Then you make a curved line, not like a straight line. And then we won't work with that today. That's a bit too complicated, okay? And maybe I'll teach you that later. But today we were working with a straight line, okay? So if you somehow get some kind of curved line like that, it's probably wrong, because today we're working with straight lines, okay? Now let me show you how to graph these linear equations, okay? And then don't worry, we'll do a bunch of practice problems to make sure you understand, because this might be a bit confusing, okay? This might be a bit confusing. So let me take an example. Jocelyn, okay? Jocelyn gave us a very good example. Y equals 6x minus 2. Y equals 6x minus 2, okay? And linear equations, they have the two variables, y and x, right? So you have them, okay? So now, how to graph linear equations? So to graph a linear equation, you have to put this equation into slope-intercept form. And to put this equation into slope-intercept form, you have to follow this, okay? Slope-intercept form is like this. Y equals mx plus b, okay? And Jocelyn's example is already in slope-intercept form. So my example, y plus 2 equals 3/4 x, that isn't in slope-intercept form yet. So sometimes you have to actually solve the equation first and put it in slope-intercept form before you can graph it, okay? So they're always in this kind of form. Y equals mx equals plus b, okay? M equals the slope of the line, and b equals the y-intercept of the line, okay? So b is the y-intercept, and m is the slope. So does anybody want to take notes on this? Because this might be kind of confusing. Maybe you want to review. Okay. So Rayshan says he needs to take notes. So I'll leave them up for a little bit, then he'll move on, okay? So please, if you need to take notes, please do. This may be a bit confusing for you, so it'd be a good idea to take notes. And if you do not need to take notes, then please review the material that I've taught so far. Okay. So I'll give you a few moments. Okay. Rayshan is done. So let's move on. Okay, so now moving on to how to actually graph linear equations. So let's just graph Jocelyn's example over here, okay? And, okay, you need to find the slope in the y-intercept form. Y-intercept first, okay? So let's find it, okay? This is very easy, right? Because I already gave you what m equals and what b equals, right? So the numeral before x, the numeral multiplying x, is going to be the slope, right? So we have our slope 6 right here. But usually it's y2 minus y1 over x2 minus x1, right? So why isn't it in fraction form? Well, it doesn't need to be in fraction form because it's an integer. You can just express it as 6 over 1. Also, you can express it as negative 6 over negative 1, okay? So then, let's move on to our y-intercept. Our y-intercept, do you think it's 2 or do you think it's negative 2? Okay? It is actually negative 2, okay? So please include the sign before the y-intercept. Why? Because if this equation can also be written as y equals 6x plus negative 2, okay? So don't forget that the y-intercept is negative 2, okay? So the first thing you need to do when you graph this on a coordinate plane, you have to find the y-intercept, okay? So let's find the y-intercept. It's negative 2, right? So let's find that point and make a point right there, okay? So that is negative 2, okay? That will be our y-intercept. Now, maybe you're wondering why the y-intercept is just a single numeral. Why isn't it like the x and like this common form? Okay, so when we use slope-intercept form, we don't actually include the x, and you might ask why. Well, why? The x is always the same, so you don't even need to know the x. It's always the same. Now why? Because the y-intercept is always on the y-axis, and it doesn't go anywhere else, okay? It can't be over here. Then it wouldn't be the y-intercept. Can't be on the x-axis. Then it'd be the x-intercept, okay? The y-intercept is on the y-axis. Can't be on the x-axis or anywhere else. That's why x is always 0, okay? And then some y, okay? So you don't even need to know the y. You just have to plot it, this y coordinate, on the y-axis. And moving on to our next step, okay? So our slope is 6 over 1 or negative 6 over negative 1. So remember, y is on top. Remember, vertical change first, and then y on top, x on the bottom. So let's do y first, okay? So we have our 6 right here. So positive 6, we move up, right? So 1, 2, 3, 4, 5, 6. Okay, so everybody should get a point 0, 4 on the y-axis. But don't forget we have to move right. 1 because we also have this point 1. So let's move right, and then you can get this point. Okay. So now let's graph -6 and over -1. Okay. So usually you can just graph the line with 2 points, but I like to do it using 3 points. Okay. And this way you can include the other slope too. So remember, you have to go down by 6 now that it's -6. So 1, 2, 3, 4, 5, 6. We go down, and then to the left, 1. There we go. And now you see that these points actually form a line, right? They form a line, okay? My line isn't particularly great, about right here. So that is about a straight line. And the points aren't exactly accurate, but you can see that it forms a straight line, okay? So if I were using like regular graphing paper, then it will form a perfect straight line, okay? And you have to make sure that your answer is correct. How? Remember the useful tips I taught you. We have a positive slope. So even before solving the problem, you should know that your line looks like that, right? You should know. It could look like that, look like that. But your line should be in first quadrant or third quadrant, okay? So now you can check your answer. Let's say you have a line that looks like this. Well, when you look at it, this line has a negative slope, right? And that's not the case in this problem. So when you see that you have a line like this, you need to recheck your answer, okay? So that is a pretty helpful tip to use when you are double checking your answer. So now please try and solve your own, okay, linear equations. So this is the first problem. Y equals 4x plus 3. Now, I've already put this in slope-intercept form for you, okay? So this is already in slope-intercept form. So please finish this problem and put it in the chat box, okay? Okay. So does anyone have a answer yet? And Tracy, thank you for subscribing. Okay, so I'll give you a few more moments to try and solve. I'll put the slide up, okay? And remember the useful tips that I taught you. And make sure your answer is kind of reasonable. If it's not, please double check your answer. And put your answer in the chat box when you're done. Okay, so who can also, okay, I forgot to say this. When you're putting your answer in the chat box, you can't literally like graph a line in the chat box. It'd be pretty weird if you did. But please put the 3 points, okay? Remember, when I was graphing this line, I had 3 points. So please put the coordinates of those 3 points that you have. And those 3 points should form a straight line. So just put the coordinates of those 3 points that you have, or any point on the line, okay? but I prefer you just put the y-intercept and the other 2 points, okay? So just put those 3 points in the chat box, and then you will be done with your answer, okay? So is everybody still working? Yes or no? Or do you just don't know the answer? Okay. Is everybody still working? Yes or no? Please put in the chat. Okay. Well, there aren't any answers yet, so I'll give you some more time to work on this. Great, Shan. Okay, I'll explain the slope part again. Okay. So when after you find your okay, I'll explain the slope part in this problem, okay? Some of you are not getting it, so I'll explain the slope part in this problem, and I'll walk you through how to get it. Okay, so first, remember, let's find the y-intercept, okay? We have a coordinate graph over here. Y-intercept is 3. 1, 2, 3. Get this point, right? And remember, you have to start from this point, okay? So this kind of is your new origin, or new origin, okay? And then we look at our slope. Right here, it's 4, okay? And the slope is 4 over 1, or negative 4 over negative 1, okay? So remember, start from the y-intercept. So let's start from the y-intercept. Go up 4. 1, 2, 3, 4. And then we went up 4. Now let's do the x, okay? Go to the right by 1, okay? So go to the right by 1. And then you see these make a point, okay? And then, right, let's do the negative 1, okay? Go down by 4. 1, 2, 3, 4. This will be our point. Then go to the left by 1. There we go. And then you see it forms a point. And now the 3 points make a line, right? They make a line, okay? So does everybody understand the slope part now? Okay, no problem, Rayshan. Okay. So now our last problem, okay? So this one is not in slope-intercept form, okay? This is not in slope-intercept form, so please put it into slope-intercept form, and then we can put it into a straight line in the coordinate grid. So now that I've walked you through question 1, I would like you to try and solve number 2 on your own and put it in the chat box, okay? So I'll be waiting for your question, your answer in the chat box. Okay, I'll give you a few moments to solve. Okay. Tracy, I do not have an Instagram account. But you can follow my YouTube channel or something like that if you're interested. Okay, Jocelyn, very good. You put it into slope-intercept form. Okay, very good. So does anybody have some answers for me? Please put the 3 points. Okay, remember I walked you through this one. We have our 3 points, right? So please put the coordinates of the 3 points. So let me give an example. This point would be 1, 7, right? 1, 7. And then this point, the y-intercept would just be 0, 3, right? And then our last one would be -1, -1. Okay, so just put the coordinates of 3 points in the chat box, okay? Does anyone have more answers? Okay. Who can give me the 3 coordinates of the 3 points besides the slope-intercept point? Okay, we don't have much time left in this class, so let me just walk you through the thing. So remember, we have to move the x to this side. Remember, we did this in our previous algebraic equation classes. Okay, so y equals -3 over 4x, then plus 4, right? And then you take the slope of this, correct? And let's see. Rishan actually multiplied every term by 4, I think. Okay. Now, Rishan, you don't actually have to do that. You can just take the whole -3/4 as the slope. And then you can take the y-intercept, okay? So -3/4 can be -3/4 or 3 over 3 over, let's see. Okay, my pen is malfunctioning right here. Okay, something like that. 3 over -4. Okay, now it's good. Let me try to draw that 3 again. Okay, whatever. And then these are our 2 slopes. So now we have our coordinate grid, okay? And what is our y-intercept? Our y-intercept is 4, right? So 1, 2, 3, 4, okay? That we just find our y-intercept wherever it is on the coordinate grid. And now this is, we have to find the slope now, okay? So the y, we just go down by -3, right? It's even as if it's a fraction, it's not that hard, okay? You don't have to simplify it. You just go down by 3, 1, 2, 3, you get here. And then you have to go to the right by 4. 1, 2, 3, 4, right? Then you get this point. Okay? And then we covered this slope, so we don't need that anymore. Let's cover this slope. Okay. So the 3 right here. We go up by 3, right? 1, 2, 3. And then we get this point. Now we just have to go to the left by 4, right? So 1, 2, 3, 4. Here we go. And then you notice that these points make a straight line. Okay, that is super horrible line. Don't mind me. Just gonna erase this line. There we go. Okay. Kind of straight line, but I'm sure you get the idea. And now we can check if our answer is reasonable. So let's see what kind of slope we have. We have a negative slope. And does it fit the picture? Does it fit the picture? Let's see. Remember we told you negative slopes have to go like this. And then our line is exactly like that. So then we realize that our answer is reasonable, okay? So does everybody get where I'm coming from, okay? Okay. So now it's the end of my class. So thank you for listening, everyone. And please subscribe to my YouTube channel and like all the videos. And bye, everyone. Okay, let me stop recording. Oh my gosh, technology. Oh, there we go.